Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, continuing American Girl by Tom Petty. We'll check back in with Tom a little bit later so we can continue to discuss probabilities using a calculator. This is part 2. We only have one, count 'em, one more example to go. So, what do we have here? We have the time taken by students to complete a puzzle is normally distributed with mean 28.3 minutes and standard deviation 3.6 minutes. Calculate the probability that a randomly selected student took at least 30 minutes, so that would be 30 minutes or greater, to complete the puzzle. So what does this look like? So we have a random variable x. It is distributed as a normal distribution, which has a mean of 28.3 and a standard deviation of 3.6, which we'll put in the form of variance. And so we would have a normal curve. Let's see how we do with the curve. Of course I will do awesome because I am awesome. And the mean right here is 28.3. And we are interested in, let's say 30s here, everything to the right of 30, including 30. So we just have to find the area under that curve. Now this is as x goes to infinity, and we can't do that, remember. But what we can do is approximate infinity. And so we'll start with our lower bound, which is indeed 30. Then we'll approximate infinity by using the largest number possible on this calculator, which is 9 times 10 to the 999th power. And then we plop in our mean, which was 28.3, I think. Is that right? Let me check. Of course it's right. How could I possibly be wrong? And then our standard deviation is 3.6. So boom, chugga-lugga-lugga. We have a standard deviation, no, I'm sorry, we have a probability of 0.318. So the probability there would be approximately 0.318. No big whoop. Okay, now we got to think about this a little bit for part B. Calculate the probability that out of 10 randomly selected students, at most, half of them took at least 30 minutes to complete the puzzle. Okay, so you have to recognize this as a binomial distribution. Why? No pun intended there. I accidentally wrote y because I used x here. The random variable y is distributed as a binomial distribution. Why is it binomial? Because they either took at least 30 minutes or they did not. So we have two choices, at least 30 minutes or not. Yes, success or failure is how we have to look at that. Okay, so that would be number of trials, 10, yes. And then the probability, 0.318, okay? And we want to find out what is the probability that y is less than or equal to 5. What is that equal to? All right, well, that's very simple, very easy on the good old TI Inspire calculator. Now we got to go back to menu. We got to do probability. We got to do distributions, and so we're going to go to binomial, and it's cumulative. It is cumulative because we don't care about just 5. We care about 5 or less. Okay, so the number of trials, let's see, that would be 10, because there's 10 students. I almost said 5, sorry. The probability of success is 0.318. Yes, our lower bound is 0, and our upper bound is 5. So, because it's from 0 to 5, or less than 5, and we get the answer 0.938. Isn't life wonderful? So, there you have it. Anytime you have a yes or no, success or failure, you must use the binomial probability distribution. Okay. That is all that we have. Now, let me just explain something here. You might say, wait a second. Half of them, minutes is continuous, but we weren't interested in the minutes. We were we are interested in the number of students. That is discrete. So it's 5 students, 4 students, 3 students, 2 students, or 1 student. Why 5? Well, 5 is half of the 10 randomly selected students. Okay, hopefully that clears up any confusion. I hope you enjoyed it. I wonder how Mr. Petty is doing. Let's see how he's doing. Let's bring him in silently, because I, ladies and gentlemen, have done all the damage I can do here. So I am... Ouch!